Okay, let's just start with a quick review. So, without looking at notes or your book, can you identify the input, output, and the coordinate for the sine and the cosine? This is what we've been talking about, and this is central of great importance to trigonometry. So, compare your thoughts with the person around you. So we'll just take a minute to do this. Okay, for input, for sine, angle, right? Is that sufficient? Is that good? Angle?
No, it's the angle is whatever counterclockwise starting with 3 o'clock position.
Yeah, so there's lots of angles we could define, and only this particular angle will work with the way we define sine, okay? So if we don't have this angle, the sine, it won't be right, okay? So it's this angle, the angle swept counterclockwise from the 3 o'clock position, okay? So that can be in any unit that we want, radians, degrees, gradients, percent of the circle, whatever, doesn't matter. But we like to emphasize radians because radians gives us this nice connection to radius lengths and arc length, right? So radians, that's the nice advantage to radians is because it connects us directly to arc length. Okay? What about the output for sine? Yep, it's vertical distance above the horizontal diameter. That's in radius lengths. Okay, what's the least value that could be? What's the least value that could be? Right, so at the bottom of the circle is the lowest that we could be. We're 1 radius length below the horizontal diameter. So -1, you can't get any lower for sine than -1. And what's the greatest that could be? The top of the circle, 1 radius length above the horizontal diameter. Okay, so what coordinate are we talking about here with sine? Which coordinate? Y coordinate, right? Okay, what about the angle for cosine? The input angle.
Shouldn't it be the same thing?
Exactly the same. It's the exact same input, right? Exact same input for cosine. What's our output of cosine? What does cosine give us? That's right. Horizontal distance right of the vertical diameter. That in radius lengths. What's the least it can be? -1 on the left side of the circle. What's the greatest it can be? 1. You can't get any further away than 1 radius length if you're staying on the circle, right? The furthest away you can get is 1 radius length. Okay, what coordinate is this? That's x, okay? So this is review, and this is crucial to understand everything that we're talking about. It all builds on this, okay? Can I take this down? Any questions about that? All right, so how about, so just looking at this right here. Circle barely shows up. Okay, so how is the cosine represented on this picture? How is the sine represented? How is the angle represented? And then estimate the values of the angle, the sine, and the cosine. Okay, so how are they represented? So all three. So the angle theta, the cosine of theta, and the sine of theta. How are they represented in the diagram? And estimate all three values based on this particular setup. Okay? Talk to the person next to you. Go. Okay, so half of you should be talking. It should be like a party, right? So that's the one time when everyone in the room is talking at the same time. Party, right? Anyone got an estimate for that angle in radians? Should all be able to estimate that angle in radians? Ooh, that's pretty precise. Yeah, that's pretty precise. But yeah, so around what? All right, he wants 2.1. That's great. How did he know that? So were you thinking something around 2? If you weren't thinking something around 2, then you got to go back and review this idea of angle, right? So the angle theta is the same as? What's the same as? That number. Anybody? How many radius lengths is subtended by that angle? So here's the angle. So how many radius lengths are subtended by that angle is the same as the angle measure in radians. Okay, and it's about 2, because 1 is about here somewhere, and maybe 2 is about here, so yeah, a little bit more than 2. Okay, what do you so how is the cosine represented in this diagram? How is the cosine represented? Yep, the horizontal line attached to the bug. And what do you estimate the cosine to be here? About? You said negative 0.5. Agree with that? Negative or positive? Yep, negative because it's to the left. And then if this, here's one radius length right there. Yeah, so pretty close to 0.5, maybe a little bit further, 0.55 or something. A little bit further than halfway over. Okay? What about the sine? How is that represented? Somebody knew. How is that represented in this diagram? The sine.
Positive 0.8.
What's that?
Positive 0.8.
He wants to estimate it at positive 0.8. And how is it represented in the picture?
As the y-coordinate, so the distance from the horizontal diameter.
Yep, this red line right here, right? This represents sine of theta right there. And we're estimating that to be about, or sine of 2.1, which is about 0.8. Positive because? Above the horizontal diameter. Okay. This is more review. Any questions on that? Okay, so what we're going to do on Wednesday is I'm going to give you this. Okay? Well, actually, let's hold on a sec. Let me introduce that a little bit. All right, so here's our circle, okay? And we said that how can this represent? It has radius of 1. But how can it represent any circle? How can it represent any circle? What would the 1 mean? Yeah, so if all these values here stand for radius lengths, then we're talking about any circle, whether it's 800 meters in radius, it's still 1 radius length out to the edge. Whether that's 800 meters or 3 inches, right? So we can represent any circle by the unit circle, thinking of the units as radius lengths. Okay, so what am I showing here? What am I showing? What types of angles am I showing now? Showing radius lengths. So what angle in radians is this one here? 1, 2, 3, 4, 5, and 6, right? So that's a familiar picture. Okay, these are angles swept counterclockwise from 3 o'clock using whole numbers or integer numbers of radius lengths. Okay, so that's the advantage. We got these nice numbers. Whole numbers are great to work with, but there's a great disadvantage to working with these particular angles. What's the disadvantage? What's that?
They're not neat.
Yeah, so they have no relationship to symmetric places on the circle, right? Like if we wanted to talk about some angles that had nice symmetry with the axes, these have no relationship to that. Okay, so in order to get those angles, we start by defining how many radius lengths or how many radians are exactly 1/2 of a circle, which is what? That's pi. So it's about 3.14, exactly pi, to get halfway around. Okay? And so to get it exactly, we need all the decimal places of pi to infinity. Gets us the exact number for that many radians for half a circle. So starting with pi, we can then find angles for the symmetric places on the circle, which looks like these. So, okay, so now this is all the symmetric places on the circle. So we're about to kind of fill in this whole thing, and so let me talk about this. So on Wednesday, I'm going to give you a blank one, a blank sheet of paper that looks just like this for your quiz, and you're going to fill it in. So it's an easy 100 if you want it, okay? And I'm about to do it right now. So it's an easy 100 if you want it. I'll give you this exact sheet, and you'll fill it in, and you get 5 minutes to do it. You get 5 minutes. Okay, so let's do it. Okay, so it begins with, again, what is our first angle? It all starts with this angle over here, half of a circle, which is? That's pi. Okay, so that's, if half a circle is pi, then what's a quarter circle? Pi over 2. All right, so it's all about counting. So now we can count quarter circles. 1 pi over 2, 2 pi over 2, bottom will then be 3 pi over 2, which is like 1.5 pi, right? Here's 1 full pi, and we're going to go another half of pi. Takes us to the bottom of the circle. So 1, 2, 3, 4 pi over 2, which is the same as 2 pi. Okay, so these are the first basic angles. All right, so now if we know cosine and sine really well, we can answer what is the cosine of 3 pi over 2. What's the cosine of 3 pi over 2? -1. Is that right? He wants 0. Someone else wants 0. Is it 0 or -1? The cosine. So here's where this is why we reviewed those and did those over and over again. Really got to know, what does cosine spit out and what does sine spit out? Cosine spits out horizontal distance to the right of vertical diameter. What is the horizontal distance to the right of the vertical diameter here? 0. Cosine of 3 pi over 2 is 0. Okay, what's the sine of pi over 2? 1, because sine is vertical distance. Okay, what's the cosine of pi? I heard 0 and I heard -1. No, what's the cosine of pi? -1. Cosine is the horizontal distance to the right, or the x-coordinate, which is -1 at pi. Okay? All right, so then we can go ahead and we can split up each quadrant again in half. So if pi over 2 is a quarter circle, Then what's an eighth of a circle? Pi over 4. Okay, so now we can just count. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Does it make sense? 4 pi over 4? Yep. 5 pi over 4, 6 pi over 4, 7, 8 pi over 4. Does it make sense? 8 pi over 4. Yep, 2 pi. So you can just count pi over 4s. 1, 2, 3, 4, 5, 6, 7, 8. And then you simplify it when you can. Okay, and then your degrees, same thing. So you know what half of a circle is in degrees. What is it? 180. So therefore, half of that is a quarter circle, which is what? 90. Half of that is an eighth of a circle. For now, so you can just keep adding 45 degrees, and you can get all the angles that I'm showing here. Okay, so now what about the, we got some new spots here in the circle, so what about sine and cosine of those? So this will help to see that. Okay, so estimate, if we wanted to estimate the cosine of pi over 4, where would you look to do that? A, B, C, or D? If you want to estimate the cosine of pi over 4, would you look A, B, C, or D? Cosine, you would look here. You want the x-coordinate of that point, so you would look here. And so what is it about? Just about 0.7, right? So we're thinking this is about 0.7. We're saying that's the cosine of pi over 4. Where should we look for the sine of pi over 4? Yep, we look up here. Alright, so that's the sine of pi over 4. Also, about 0.7, right? So it should make sense, though, if we go exactly halfway through the quarter circle, that's the place where the x and y coordinates will be the same. And that's true. So we're going to have the same x and y coordinate. So to actually solve for that, so what can I do here? So what's this distance right here? That's cosine or sine? That's cosine. We'll call it A. This one is? That's sine. And by symmetry, since we're halfway up the half of a quarter circle, by symmetry, that's going to be the same. So we can also call it A. All right, so here's the quiz. How long is that? There to there. So easy it's hard, right? So from there to there. What's that? Radical A. Any other guesses? So this starts where? At the center of the circle? And where does it stop? At the circle? So what is that? It's just 1. That's a radius, right? It's a radius. It's the radius of the circle. So now, how can we solve for A? So what we're trying to do is we've estimated cosine and sine to be 0.7 by looking at the picture, but we want to get it exactly. We want to get cosine and sine exactly. How can we do that? We've got A, and 1. It's your favorite formula in math, right? A squared plus B squared equals? But what's the trick here? Look, A and B are the same. We called it A, right? And what's C squared? 1 squared. All right, so 2A squared equals 1. A squared equals a half. A equals? Now, algebraically, it's plus or minus a square root of a half, but we have positive distances, so I'll just take the plus, okay? And that is the same as Square root of 2 over 2. So put that in your calculator. Find the square root of 2 over 2. What are you expecting it to be? Close to 0.7. Put it in. What'd you get? 0.707 is a good approximation. 0.707. Exact value, radical 2 over 2. Just like pi is an exact value for the angle, the exact value of the cosine and the sine is radical 2 over 2. As soon as you do this decimal, it's an approximation. Why? Because those decimals go out for forever. Question?
Which one would you want us to put on the paper when we're writing it down?
It kind of depends. So, like if you're in an application problem, like in the real world, so we want some good approximation. If it's like we're talking about feet or inches, but if it's just purely working with geometry and you want exact values, then you use square root. So it depends on the context.
On the quiz on Wednesday, if you want
Exact. Yeah. So we want exact values for the quiz. That's right. Okay. So then we know that what are the coordinates of this point then exactly? Radical 2 over 2 and so both the sine and the cosine are this number, which is the number of radius lengths to the right and the number of radius lengths above. Radical 2 over 2, which is about 0.707 radius lengths. Okay, now from that we can get the sine and cosine of all these three other angles. So for instance, what's the sine of 3 pi over 4? The sine of 3 pi over 4. Okay, is it radical 2 over 2? Is it positive or negative? Sine is positive there because above. How about the cosine of 7 pi over 4? Negative radical 2 over 2. Cosine.
No, it's positive.
Positive. What does the cosine mean? Cosine is horizontal distance to the right. Are we in positive or negative territory in terms of horizontal distance to the right? Positive territory. Because we're to the right. So the cosine of 7 pi over 4 is positive radical 2 over 2. Okay? What about the sine and the cosine of 5 pi over 4? Both negative radical 2 over 2 because we're to the left and we're below. Okay, so both the sine and the cosine are negative radical 2 over 2. So for all four of these angles, all you need to know is radical 2 over 2 and then know exactly what the sine means and the cosine means and apply either positive or negative correctly. Okay, does it make sense? Okay, so then the next thing we do is we split the circle up into, or a half circle into sixths. Okay. So again, half of the circle is how much? Pi. And so then I've split this half circle up into 6 equal arc lengths. So therefore this angle right here is pi over 6. Okay, again, so now all you have to do is count. 1, 2, 3, 4, 5, 6. Okay, ready? So this is 1 pi over 6. Then 2 pi over 6. Top of the circle. 3 pi over 6. Does it make sense? 3 pi over 6 is the same as pi over 2. So 1, 2, 3, 4 pi over 6. What's this? 5. You just count, right? 6 pi over 6. Does it make sense? 7 pi over 6. 8 pi over 6. Bottom of the circle. Is it right? 9 pi over 6. Yeah, 3 pi over 2. So 9, 10, 11, 12. Does it make sense? 12 pi over 6. Why does it make sense? 2 pi, we know is the full number of radius lengths around the circle.
So these are the two, right, adjacent to the pi over 4 and the d pi over 4.
Yeah, the pi over the fourths will be in between each of those in each quadrant. Is that what you mean?
Yes.
Yeah. They'll end up in between.
Can we simplify all of those?
Okay, so what happens is we basically get 8 new angles, and we group them in 2 groups of 4. So here's the first group. We look at these. Okay, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, because all of these have the same horizontal distance to the right and vertical distance above or below, just a matter of positive or negative. Okay, so what would you estimate to be the sine of pi over 6? The sine of pi over 6. What do you think? Positive, you would look right here, right? For the sine, it looks like positive 0.5. And I will tell you that it is exactly 0.5. The sine of pi over 6 is exactly 0.5. So that's this right here. Not approximate, it's exactly 0.5. And that's the sine of pi over 6. Okay? So now we can use that to solve for, the same way we did before, we can solve for the cosine of pi over 6. So what's that distance right there? Still 1. Oh, I had it. Alright, so that's 1. And then this is I'm telling you it's exactly 1/2. So what's left to find? The cosine, right? So this right there is the cosine. What do you estimate the cosine to be? So this is 0.8 right here, and that's 0.9. Yeah, so someone said 0.85. That's pretty good. Somewhere between 8 and 9. So the cosine of pi over 6 we're guesstimating to be about 0.85, but we want to find it exactly. How would we find it exactly? What are we going to do? So call it A. Then what would be true? A squared plus? What's B squared here? Same thing? A squared again? No, I told you it was 1/2, right? I told you that the sine is exactly 1/2. Equals? Make sense? So this unknown distance to the right, that's our cosine, which we want to get exactly. That squared, plus the sine squared, or the height, vertical height, which I'm telling you is 0.5 exactly, equals 1 squared. So here we get a squared plus a fourth equals 1. So a squared equals 3/4. So a equals square root of 3 divided by 2. Again, that algebraically there would be plus or minus, but we want the plus because it's a distance. Okay, so we expect radical 3 over 2 to be about 0.85. So put in your calculator. What do you get? As an approximation, radical 3 over 2. 0.866. Okay, so review with the person next to you. Do the sine and cosine of all 4 of those angles. So what's the sine and cosine of pi over 6? What's the sine and cosine of 5 pi over 6? 7 pi over 6? 11 pi over 6? Go. Take a minute to do it. Okay, what's the cosine of 5 pi over 6? The cosine of 5 pi over 6. Exactly. She wants negative square root of 3 divided by 2. Agree? For the cosine of 5 pi over 6. That's right. Okay? It's going to be this 0.866 number, right? You see it, but it's going to be negative. Or it's the same distance that we went this way, but now we're going left. Okay? So that's the cosine. What's the sine of 5 pi over 6? So negative radical 3 over 2. What's the sine of positive 1/2, she said. That's it. It's the same as over here, because we're at the same distance above the horizontal diameter that we were here. So there's the cosine and sine of that. Okay? What's the cosine of 11 pi over 6? Positive or negative? Positive radical 3 over 2. It's the same as the x-coordinate at that point. So our cosine here is radical 3 over 2. What's the sine? Negative 1/2. Okay, and then the other 4, so that's the first group of 4 for when we divide into 6. What do you notice about the other 4 angles? Okay, but what do you notice about numerically about those angles? They all can be simplified into thirds. So this one is pi over 3. This is 2 pi over 3. 4 pi over 3, and 5 pi over 3. So you can start getting them just by counting the sixths, 1, 2, 3, 4, 5, 6, etc. And then those 4 can simplify into these angles that are in thirds. Okay, and so then now we're looking at those. Now, because we've got symmetry, we're splitting the quadrant up into 3 equal angles of pi over 6 each time. How do we get the coordinates of that point up there related to right here? Yeah, now you're just going to switch. Notice that here now the cosine goes right through 1/2, and the sine is the 0.866 number. So everything's just switched. So what's the cosine of pi over 3? 1/2. What's the sine of pi over 3? Radical 3 over 2. So now they're just all switched. And so for these angles here, you just need to apply, you got the right cosine and sine, just apply the right positive or negative. All right, what's the sine of 5 pi over 3? What's the sine of 5 pi over 3? Negative radical 3 over 2. It's below, and it's there at the negative, that 0.866 number. Okay? What about the cosine of 2 pi over 3? It's negative 1/2 radius length, or 1/2 radius length to the left. So it's negative 1/2. Okay, so anybody have a question? What's that? Yep, the degrees for all the angles. So it's just, again, you know half the circle is 180, right? So what's 1/6 of that? 1/6 is 30. So you can just add 30. Just keep going around and adding 30. 30, 30, 30, 30, 30, 30. Just keep adding 30 as you go around. So here's what we call the 16 key angles. We just derived them all. The 16 key angles. So let's do angle measure first. So what is our angle measure here? 0. Pi over 6. That's our pi over 4. So remember, this is 1 pi over 6. This was 2 pi over 6, which is the same as pi over 3. And then here, pi over 2. Okay? So, degrees. Remember, this is 1/6 of half of a circle. So in degrees, 30. Okay? So this isn't part of the 30s, right? So 30, then 60, then 90. Okay? So now this one is half of 90, half of a quarter circle, which is 45. Okay, so there's our angles. And then you're responsible for keeping going. I'm just going to do the first quadrant here. You would just keep going, right? Just keep going. Okay, cosine and sine. Radical 2 over 2, radical 2 over 2. Remember, that's about 0.7. It's about 0.7. There's our cosine and sine of that. Okay, pi over 6, cosine and sine. Cosine is? That's our radical 3 over 2, that 0.866 number. Sine, 1/2. 60, or pi over 3. Cosine is the 1/2. Sine is radical 3 over 2. Okay, we never did 0 and so it's 0. What's the cosine? 1. Sine? 0. Pi over 2. Cosine? 0. Sine? 1. And then from these, we can get all the other sines and cosines, or all the other coordinates, just by applying the correct positive or negative to these values. So your quiz will be then to finish the whole circle, both degrees, radians, and coordinates, cosines and sines. Anybody have a question? Does it make sense? So I'll post a blank one, just like you'll get in class on Wednesday, so you can print it out and practice. Okay? And you can find, the answers all over the internet. You can find ones that are filled out, of course, all over the internet. Just do unit circle, Google unit circle, and click on images, and you'll find it. All right. But so the point is that when we're in context doing problems, we don't want to fumble around trying to remember what these values are, both the angles and the x and y coordinates. We just want to have them. We just want to know them, so that we can focus on the kind of the real interesting parts of the problem, okay, and the reasoning aspects of what's going on, rather than stumbling on these kind of facts, right, on the trig facts of the circle. Okay, last chance. Any questions? Okay. Okay, so I had you do a worksheet about swinging the ball around. Okay, so just pretend the bug is now the ball swinging around. And that was on, was it page 285 or something? Yep. So on page 284, we had the ball swinging around at 2 radians per second. So we're just skip right to page 284, and the ball was going around. So instead of the fan, now it's in the bug. It's the ball, and it's going around at 2 radians per second. So what are we doing now? We're bringing time into it. We didn't do that before. All we were talking about before was angle and resulting location on the circle. Well, now we're bringing time into it, which is a very common thing with all these applications, because things take time to go in a circle. So we can look at coordinates based on time rather than based on angle. So we want to really understand, say, the relationship between time and angle here. And so if you're ever not sure, go ahead and set up a table. Excuse me. Okay, so if this is twirling at 2 radians per second, then after 1 second, how many radians have we gone? 2, right? So after 3 seconds, yeah, if it's going 2 radians per second, it means every second the ball goes 2 radians. Okay? So in 3 seconds, 6 radians. In 5 seconds, in 20 seconds. So in t seconds, how many radians does the ball sweep out in t seconds? 2 times whatever the time is. Okay? So the number of radians swept out is always twice how many seconds have gone by. Excuse me. So now this here, so here's the ball flying around in the circle. So what am I graphing here? Am I graphing the cosine or the sine? Am I graphing the horizontal distance to the right, or am I graphing the vertical distance above? So what is the horizontal distance starts at what? 1 and goes down to 0, then to -1, back to 0, and back to 1. So that's what I'm graphing here. So this is a graph of cosine. So let's call that F. So this is number of radius lengths. If it's just plain cosine, then we're talking about between 1 and -1 radius lengths to the right of the vertical diameter. Okay, so in what angle does the ball go from 1 to 0? So what angle is this right here? So it's 1, this is saying it's 1 radius length to the right, and then it heads down to 0 radius lengths. That's the top of the circle, right? Top of the circle, it's neither to the right nor the left, so it's 0. All right, and then it goes out to -1. What angle? It's pi. Where in the circle are we here? Where it's back at 0. Where in the circle? Bottom of the circle, you're neither left nor right, so you're 0. You're 0 radius lengths to the right, and then back to 1 radius length to the right at 2 pi. So what if the ball keeps going, what will the graph look like if we keep going for angles greater than 2 pi? Yeah, the ball will continue going through the same horizontal distances to the right, and so we'll get the same output values again over what's called a cycle. Okay, so this is called a cycle. And this value, 2 pi, is the interval of input, right? Our input's angle, so this is the interval of input that results in 1 full cycle of output values. So the interval of input, that gets us 1 full cycle. So starting out at the right, to the middle, out to the left, back to the middle, out to the right again. So there's a special name for that. Anyone know what it is? The interval of input that gives us a full cycle of output values is called, starts with a P. Period. Okay, so that's the period in terms of the angle. Now, what if we wanted to write this function in terms of same function, but instead of angle, in terms of t? What did we find that the angle equals? It equals 2t. So g of t would be what function? Right. So it would be cosine of. Remember what we call that thing, 2t? From our quiz on Friday? Argument, okay? So the argument of cosine is always what kind of quantity? The argument is always what kind of quantity? Angle. Angle is always what goes into cosine. But we can have an expression of angle in terms of something else, like this, time. So here we've got an expression of time that gives us angle, and so this is called the argument. Okay, so if we want to know, so the period in terms of angle is 2 pi. So what if we want to know the period in terms of t? Well, what we're saying then is we want to pinpoint what exact time, call it t sub p, okay? What exact time, we know that's the angle. This is, if 2t is the angle and we want a full cycle in terms of time, what's the full cycle in terms of angle? 2 pi, right? So 2t is the same as theta. So when theta makes a full cycle, the corresponding time will be the time it takes to make a full cycle. Does that make sense? So then we can solve for the period, the time period, which would be pi, right? 2 pi over 2 is pi. So in terms of seconds, so I'm going to make a new scale, seconds, down here. So this is angle, theta up here. We'll make a new scale in seconds. So halfway around, we'll take pi over 2 seconds. Quarter, we'll take pi over 4. And then 3/4 of the way, we'll take 3/4 pi seconds. Okay, so what if you had something more realistic, like 9.7? You had 9.7 radians per second, then what would the angle be? Yep, it'd be 9.7 t. So these would be no good anymore. We'd have to redo those. Okay, and then our g function would be cosine of 9.7 t. And now to get the period, we're saying, so 9.7 t is the angle. So the particular value of time that corresponds to an angle of 2 pi would be our time period. So 9.7 t is our theta. So at what particular time gives us a full cycle of theta, or 2 pi? So that would be, so get a decimal approximation for that. 2 pi over 9.7 is about what? That's 6.5? About. So now it's going around in a circle every 0.65 seconds. So that would be the period in terms of t. In angle, it's still 2 pi. So then we'd have half of that for halfway around. Or was that 0.325? And then you do another half of that for the quarter circle. Yeah, so you do half of that and then add that on here to get that. So this is the idea of period. We have period in terms of angle, which for cosine and sine, for the argument, is always 2 pi. And then based on how fast it's turning around, you can get the corresponding period in time by doing this. And what the angle the corresponding time period will give you a full rotation of angle, 2 pi. So you solve for that time period that gives you that angle of 2 pi, and that's the number of seconds. Okay, does it make sense? So written homework for Wednesday, and then we'll have the blank circle, unit circle quiz.
Do you want some cough drops?
No, I'm good.
Are you sure? I
Thank
have like
you.
a whole bag.
I'm good. Yeah. Just need to blow my nose.